Hi, everybody. Thank you for joining. And I think we are ready to start because I see it's already 6 o'clock, at least our time. And yeah, so let's get this show on the road. So I'll maybe briefly do some introductions and then we can get going. So yeah, Norbert and Gabor, maybe turn on your video just in case. So the webinar will be about, as you see here on the screen, high-tech agriculture with drones and what are the current challenges as well as solutions. So in the webinar, it's first going to be me, Kristaps. I'm the product owner of UgCS, flight planning software from SPH Engineering. And then we'll also have Norbert and Gabor from Proofminder, and they will talk a bit more in details on what it is that they do and how do they use drones in agriculture specifically. Their part is going to be the biggest part now in this webinar because, yeah, hopefully it will be also quite interesting for everybody. I saw the presentation already, and I think it's worth waiting for. So maybe initially, just before we get into that, I'll just introduce about some general webinar information. So like I said, the agenda is that first, I'll explain a bit about the flight planning tools in UgCS, as well as what's new in the newest version. So a few days ago, actually, we released UgCS 4.12 version. So I'll briefly talk about what's in there. And as well, I plan to show you the software. I'm sure many of you have probably already seen it, but for those who haven't, I'll just do a brief overview of what can you expect when you start using UgCS for your flight planning. And then we'll move on to the benefits of using UAVs in the agricultural sector, which will be covered by the guys from Proofminder. The approximate duration is approximately 1 hour, might be a bit more than that, plus the Q&A section. Yeah, everybody who's here, for all the attendees, please, if you have any questions during the webinar, please make sure to put them in the Q&A section and not the chat, because questions can get lost in the chat. With all the questions that we'll get in the Q&A, we'll try to answer them. We'll answer them either over a text, because we're also joined by Valeries from our support team here at SPH Engineering. And as well, a question we get quite a lot is, so will the recording be available on YouTube? So the answer is yes. So after the webinar, or in case maybe you can't really stay up until the end, you will be able to replay this webinar and rewatch it on YouTube. But of course, for asking questions and interacting with us, this is why we're all gathered here to talk about drones, talk about agriculture. So I think then let's get started. Just briefly about our company. So SPH Engineering has been around since 2013. We're based in Riga, in Latvia. And our four main business lines are UgCS for flight planning, then UgCS Integrated Systems, where we integrate various geological sensors together with drones and help you collect data with them. And then we also do software for drone shows, as well as do custom software, as well as data processing, which is under the consulting and development project. So we have partners now all around the world, as well as we are present in various different industries. But I think let's maybe then move on to already slides about UgCS software. So for those of you maybe not familiar with UgCS, this is how the interface looks like. I'll also show you the software in action in just a brief moment. But yeah, so here you can see basically all the software is in 3D. So here you can see this is simple photogrammetry mission that has been planned over this area. And actually one of the reasons why most people who use us choose to use us is the fact that we support terrain following, as well as that we actually manage to solve these really complex tasks as far as flight planning goes. So if you need to plan complex routes, then UgCS is the tool to use in those cases. So why UgCS for flight planning? Firstly, it installs on either PC or Mac, so everything's installed locally. There's no need to use a browser interface like in some other cases, and there's no need to plan the flights on a small tablet screen. We also have a 3D interface, so we have a whole 3D globe inside. By default, we are using SRTM4 terrain elevation data, but you can also use your own custom map overlays, and you can use your own custom digital elevation models or digital surface models. You can plan flights, like I said, according to the terrain following, as well as if you know that you'll be flying in places where there is no internet coverage, you can also catch the maps for offline use. Then it does support DJI as well as other manufacturers, because for those of you who might not know that, so actually UgCS, the full name of that is Universal Ground Control Software. So we support DJI as well as other manufacturers. So you can use, for example, Autopilot or PX4 based autopilots. Some of these, if you are maybe from the US, this would include the FreeFly Alta X drone. Actually, now we're also working on support for the FreeFly Astro drone. But yeah, basically any custom drone made on Autopilot or PX4 platform is compatible with UgCS as well. So it's not only DJI, although most of our customers, about like 90%, I'd say they are using DJI. What's also good is that you can create routes from KML or CSV files. We have a specific tool set for flying with LiDAR instruments. This is available in UgCS Expert and Enterprise licenses, as well as the software architecture in the Enterprise license. It's modular. So this means that you are able to deploy the main server running, for example, in the cloud, like I think the guys from Proofminder will also explain about how they are doing this, as well as you have the ability to stream video when you are using UgCS. I'd like to maybe clear out one common misconception that's here. So I know a lot of you, if you are familiar with UgCS, you might think that, okay, so you do the flight planning on the laptop, which means you have to bring the laptop with you in the field. So that's not the case. It's true that many pilots do choose to take the laptop with them, but in fact, there are other solutions. So for example, like I said, you can keep the server in the cloud, and then in the field, you only need to have the tablet with you or the drone smart controller, and then you can connect to the server running in the cloud. Or alternatively, actually now, which brings me to my next point, the release of UgCS 4.12. So in the new version, actually, we have added support for, the feature to export routes from UgCS into DJI Pilot 2 in specific DJI format. So these are KMZ and or also WMPL files. And so with these, this actually means you can construct your routes in UgCS, export to DJI Pilot 2, and like that, you are able to not have to take the laptop with you in the field. And even in case you need to make some modifications to the route, you can do this from DJI Pilot 2 as well. So in the new version, we have added support for the Mavic 3 Enterprise as well as DJI M30. This also includes the thermal versions of these drones. But the note is that here, the support is implemented using the route export DJI Pilot 2. So currently, you can't yet connect these drones directly to UgCS. We are working on that because they're based on the new SDK version from DJI. So ability to connect them directly is also coming soon, hopefully this year. But for now, you can already plan flights for Mavic 3 Enterprise as well as DJI M30 drones, and then export these flight plans to DJI Pilot 2 and then fly with these drones. Also implemented corridor splitting, as well as the ability to plan vertical scans by using the line spacing, specifying it in meters rather than overlap. So it's also not that relevant for agriculture, I suppose, but also just some things I wanted to mention. But full release notes, of course, are available on our site. So, and now moving on to UgCS Enterprise. For those of you maybe not that familiar with our licenses, Enterprise is the top license that we have, and below that we have UgCS Pro, Expert, as well as this Enterprise license. So Pro license is for most applications. If you just want to plan simple missions, you don't need to use LiDAR and so on. So for simple missions, you have the Pro version. Expert version, which is the next one, this has the LiDAR tools in addition to all the base tools. And then the Enterprise is the full one. So what you get here is you get modular architecture. So in this case, you can have the server running in the cloud or somewhere else, and you can have pilots from the field connect remotely to that. So basically any software component, you can choose where that component should run. So for Enterprise installations, this would be the way to go. Also, this version does support live video streaming as well as video recording. Here you can also have up to 10 simultaneous drone connections, as well as the aforementioned LiDAR tools from Expert. These are also, of course, available in the top license, the Enterprise. And plus, you can have multiple SDK connections, meaning that you can run multiple apps in parallel, which are also connected to the main server. And yep, so for more information, of course, you can always go to shop.ugcs.com, read about the licenses, read about the features, and of course, we're here to also answer any questions you might have about them. So yeah, I think maybe now let's quickly jump into the flight planning demo part, and where I'll basically explain to you how do you plan the flights in UgCS, how does that work, and then yeah, after that, the guys from Proofminder will already take over. So I'll now stop the screen share just very briefly, and then let's switch on over to my screen with UgCS, and then I'll show you the flight planning part. Like I mentioned before, if you have any questions, please put them in the Q&A section. And the recording of the webinar will also be available later on YouTube for those of you who joined a bit later, just so you know, in case you missed some parts, you will be able to access the video. This will be sent to you after the webinar. So I hope that now you should be able to see my UgCS screen. So first thing you might notice is that all of this interface is in 3D. So this is currently running locally on my Mac. So there's it does catch the maps from the internet, but if you want to use it offline, you can also do so. So you can select certain map regions and then catch them for offline use. But let's maybe get started with more simple things. So as far as route planning goes, we have what's called missions, and then within a single mission, you can have multiple routes. So here you can see I already have one example. So I have a photogrammetry route planned in here. And then let's say maybe we need to plan an additional route where maybe this could be actually as well another photogrammetry route or even a corridor scan. Although I suspect for agriculture, probably let's maybe stick with photogrammetry. So to create a new route in UgCS, you just click here on the plus button, then enter some name for the route. So let's maybe let's just do flight 1, something nice and simple. Then let's select the drone for which we want to plan this flight, and let's click on OK. So now here on the side, we can choose the photogrammetry tool. Let's choose what camera are we using. In this case, let's maybe use the DJI P1 camera. And then let's go ahead and select the area that we would like to scan. So let's select this area. And then press enter to complete the figure. We can also adjust the direction angle of the survey lines, and then in just a bit, the flight will be fully calculated. Yeah, I need to now decrease the GSD just a bit, because as you can see, it does exit. So basically, based on what camera you're using, the flight altitude in the photogrammetry will be different. So in this case, I'll just have to use a lower GSD value. So let's do 0.5, because I had number 3 in there. And now let's see if all works out. Usually for longer routes, of course, it does take a bit more time to calculate them, because here it's a multiple kilometer area. And yeah, so here you can see it has been calculated. Let's see what altitude this will be. So this is 39 meters. If you want to fly a bit higher, we can maybe increase this just a bit. And so then it will be recalculated. And usually, of course, also the higher you fly, the wider will be the spacing between the flight lines. And so you can see that this route has been calculated over here. We can now go ahead and actually also open up the elevation profile. So here you can see the terrain elevation, as well as the drone's flight altitude all through the route. So you can see total distance covered in this quite large route that I planned will be 116 kilometers. So this is basically all of the flight lines combined. You can see total estimated duration, waypoint count, as well as minimum and maximum altitudes here. You can also actually adjust how well you want the drone to follow the terrain. So here you can see that actually in the middle, the software has added these additional waypoints. So the waypoints are added with a certain accuracy that is set here in the AGL tolerance parameter. So you can see, since this is set to 3 meters, this means that typically the distance between the minimum, or the delta between the minimum and the maximum altitude that's here, should be about 3 meters. In this case, it is like so. So you can see we have 79 and 82 meters in there. So if I would, for example, increase this, then less waypoints would be added in the middle, but then again, drone wouldn't follow the terrain as accurately. And in the same way, you can actually also decrease this if you want the drone to follow the terrain more accurately. So then going further, Here in map layers, you can see we're by default now using Google Satellite Map, and you can also use your own overlays in the software. In this case, I have already actually one overlay imported. So I'll just click here on focus. This was just a flight I recently did around our office near Riga. So let's zoom out and let's go here. So it's actually also one of the things that is quite useful in the software, I think, is that you can basically import your own maps, your own terrain elevation models, which do allow you to see a lot more detail compared to the standard Google Maps, at least in most areas. And yeah, so basically using this, you are able to plan your flights more accurately and be more sure that you are able to avoid any obstacles that might be in your way, because you're actually already able to detect them in the flight planning stage. Then moving on to elevation. So here as well, you can see we have an elevation overlay that is also imported together with the terrain, with the map data. So these are two separate TIFF files. Normally, when you import map and elevation, these are imported as GeoTIFF files into UgCS. So these would be like the top features to look for in the software. One additional thing I want to mention is as far as connecting the drones. So typically, at least DJI drones, they're connected using our mobile app. So it's called UgCS for DJI, and it's available on our website. So basically, it's connect your DJI drone, you install our app on your DJI smart controller, and then you make sure that both the computer as well as the mobile app or mobile device are on the same network. This isn't the case when you're planning the flights locally. Or of course, if you're using UgCS Enterprise and you're running the server in the cloud, in those cases, in the mobile app, you simply specify what is the IP address of the server that you want to connect to, and then the connection is established as well. So that's basically the idea how you can connect the software, how you can connect your drones to UgCS. And then once you have that done, you can already upload the route to the drone, press on auto mode, and then the drone will automatically take off and fly throughout the mission. To each of the mission segments, also, you can add various actions. For example, you can see here for this photogram tree route, I have added the set camera by distance action. This is the default one that's automatically added. And then if you want, for example, the drone's camera to automatically look downwards during the flight, you can also add the set camera attitude action, and here specify the tilt to be 90 degrees downwards. Yeah, I see a question from Bruce. Yeah, so can I upload my own DSM DTM file to be used instead of generic map? Yep, so that's true. The base map elevation, oftentimes, especially if you're flying in areas with quite steep elevations, these can have quite low precision. So yeah, this is what I was showing. So in here, if you go to map layers here under elevation, you can add your own terrain elevation sources. So this can be either from the geo server, or you can actually also use external sources. But yeah, most people just choose to add their own maps here into the geo server. So you can add, for example, let's call this just map. And you can see, so the icon is currently empty, so there's no map source available, but you can here click on upload and then choose your own GeoTIFF file. So just to choose file with the .tiff extension, and it will be uploaded. And when you have the elevation overlay uploaded, then actually all the flights you plan with terrain following will be planned according to the new digital terrain model or digital surface model that you have uploaded into UgCS. So I hope that answers your question. Yeah, where was I? Yeah, so here basically you can add different actions to the mission segments. So here you can see I have now also added the change camera attitude. And then one thing I want to show additionally is if you, for example, want to now export this to, let's say, DJI Pilot 2 app, like I was saying, we have this new feature. So then to do that, you just need to click here on parameters and then go to export. So then this new export window, which was added in UgCS 4.12, will open up. And then you can simply select to export this to DJI Pilot 2. And then this will export your route as a KMZ file. And then this KMZ file can simply be transferred over to the internal storage of your smart controller. And yeah, then you can simply import it into DJI Pilot 2, upload it to the drone, and fly. Alternatively, if you're using drones such as the M300, which by the way also supports the import feature through DJI Pilot 2 for the M300, you can connect it directly to UgCS. So for that drone, one alternative, if you don't want to have the laptop with you in the field, is you can actually simply synchronize the routes to our GCS mobile app that's running on the smart controller, and then you'll be able to access all the routes in the field, select them, and upload them automatically. So I'll see what other questions are there. Yeah, so one is, do you have support for spraying drones? Two, this depends on the specific spraying drones which you mean. UgCS can work with spraying drones, and but most of these would have to be based on Autopilot or PX4 at least. I think with most spraying drones, this is the case. Many of you probably might know DJI Agros drone, but with Agros, it's unfortunately not supported in DJI's SDK. So if DJI were to add support for the drone in the SDK, then we would be able to support that. But for now, unfortunately, since it's not in the SDK, we can't support the Agros drone. But other spraying drones based on Autopilot or PX4, we can support. Yeah, and then I see another question from Carlos about planning and uploading flight route if you are offline in the field. So this, I also actually want to show you guys, if you are offline, then first thing is that you won't have access to the map and to the elevation unless you have imported your own. So to do that, we have a specific section here that's called offline maps. And so with the offline maps feature, you can actually choose map segments which you want to load for offline use. So this will allow you to catch large map segments up to 100 square kilometers locally to your computer. And so then when you have that, then you are able to actually fly when you are offline. And by the way, one thing is that if you're doing the route export, then all the elevation data is saved in there. So it's basically exporting as a missile altitude. Although if you export, yeah, for DJI Pilot 2, then it's exporting relative to the ground under the first waypoint. So in that case, make sure that the drone starts from the same altitude as the altitude of the first waypoint. So ideally, it should start from where the first waypoint is or the same altitude. But coming back here to offline maps, you can press here on add, and then you can simply double click on the map somewhere to select what points should be in your map. So for example, we can do like that. If you maybe want to adjust it a bit more, you can of course always select additional points, move them around, and basically select any custom area that you wish. Next, you can enter the name. So for example, let's call this region 1, and then you can choose what map should be cached for offline use, as well as what elevation. Once you have selected all of this, then you can click here on create, and then you'll see that now this map region is being cached from the internet to your local geographic server, and this will basically allow you to fly this even in case when you will not have any internet connectivity. Okay, I'll see another question about obstacle avoidance. There's sudden change. Is it so dependent on what the type of drone is used? Yeah, so keep in mind here that as far as avoiding obstacles, it does depend on what sensors the drone has and how capable the drone is of avoiding obstacles. Actually, I answered this question today to another user on our UgCS Facebook group. So by the way, if you're not yet there, I suggest you check out our UgCS user Facebook group because it has like a ton of interesting information for you. So if you're not yet there, you can go talk to other UgCS drone pilots and see what's up. But yeah, about obstacle avoidance, I would actually say that the primary thing you'd have to focus on is the flight planning itself and making sure that there are no obstacles there. So one thing would be maybe creating a map first, then from higher altitude, and then planning the flight according to that if you suspect there might be some obstacles in the way. Also, of course, good pilot skills are quite important. So in that case, make sure you're always monitoring the FPV camera if your drone is equipped with one. And if you see any obstacle that's getting a bit too close to the drone, take over manual control. That's always, of course, safer. And I think the obstacle detection should only serve as a last resort. If all else fails, then you just, cross fingers and hope that the drone will be able to stop in time. But again, this depends on the speed of the drone. Plus, one thing is that obstacle detection systems, depending on what kind of sensors are used, also are not 100% reliable. So nothing is 100% in life, of course. But yeah, so in general, rely on your own pilot skills, rely on the fact that you know where the drone is going to be flying, what things might there be in the way. And yeah, then of course you still have the obstacle detection systems just in case. But yeah, I think I have already been talking for quite a while now, so I think maybe now let's any questions you might have about UgCS, please do leave them in the Q&A. So we will have a Q&A section after the Proofminder guys also talk about their topic specifically for agriculture. So if you have any questions about UgCS, I will also be able to either answer this in text or answer this live. But I think now I'll pass the torch onto the guys from Proofminder. So yeah, thank you for listening to me. And yeah, so now guys, the floor is yours.
Thank you very much. So let me take the word and share my screen. Okay. You see what I see?
Yep, we can see the screen.
All right, thank you very much. Okay, so very quickly about us. So we are a startup. We founded ourselves 2 years ago, beginning of 2011, and since that a lot of things happened. We got a lot of recognition from different accelerators, from different innovation awards we collected, and we are a team of 12 people today. What is more important, that we also have a lot of passion for drones and to use that technology for agriculture. So let me talk about that. Okay, so what we planned for today is to give you an insight at why it's a great thing to use drones in agriculture, and why is it important, and why we approach that subject. We're gonna give you an insight that how we actually doing our work for customers, give you an insight to our use cases, give you a demo of the platform, and then I'm going to hand over to Gabor, my colleague, who is leading our field operations, and who's going to talk about our experiences doing large, long flights with UgCS on the field, and I'll share a little bit of our secrets and learnings from that. All right, so why is it important to see the details, and why we invested into this leaf level farming technology? So you probably also sense that the agriculture is under pressure. Everyone knows about climate change. Everyone knows about the growing number of people on a finite planet. But you probably don't know that also the regulators pushes this segment a lot to be more economical, to use less chemicals, to take out land from extensive agriculture, and to be more bio and organic, and these kind of regulations are pushed on the farmers, and we have to comply with these things. What is more important probably is that every one of us just wants to eat healthier, better food every day. You and me, our kids, we all want to just benefit from technology and indeed healthier and better food. So to be able to tackle with these challenges, that there are a lot of agronomists on the field who are trying to solve this equation of pressures, and the way that they do it is that they go to their land, they go there quite often every day. They want to see the leaves, they want to see how the crops are growing, they want to feel and sense what is happening on the field, what needs to be done. And what is important is that they need to do it on quite a big land, and it's not possible by just walking around and checking everything and trying to make an understanding of what's happening in one corner of my field, what are the infections, how the plants are actually growing there, what they need. Sometimes they control hundreds and thousands of hectares, and to understand the situation daily and just decide what's the best action. Okay, so the way how we can help the agronomists is to help them to make better decisions, so they can cultivate healthier food. They can create more food from the same amount of land with less chemicals. So for that, they need to shift the decision making, the unit of decision making, from thinking in a whole field or a whole plot, and they need to focus on what's happening with each of the plants, so they can give every plant the right care, what they actually need, and just that much of chemicals, that much of fertilizer that this plant needs at that time. So this is what we made possible with Proofminder. What we did is that we combined the greatest drone technologies and camera technologies with the power of AI and computing. And we put a lot of engineering together to build a platform which is able to process very high resolution images at the large scale. So the images what we capture with drones, we can analyze with AI. We can do it in big, so we can analyze like thousands of hectares daily, and we can extract the knowledge and we can hand it over to the agronomist, so they can use it. They can decide what to do. So basically, the result of this is that they can see a yield increase. They can see that they can decrease the usage of chemicals and the input materials, and they can see basically a return of investment. And that's what drives economy, and that's what drives the green change as well. As an addition for this, we did that calculation beginning of this year, working with one of the partners, by using our technology in hybrid corn quality control to apply what we have during the season, results in a cargo ship of extra food and a lot of extra revenue for farmers, actually. And that's just one customer. And hybrid corn production is just one use case. We have multiple use cases. We're not only concentrated on that segment. Seed production is very important for us, but we also use that technology, drone technology and AI technology for other things. It can be used for weed detection. It can be used for yield assessment. It can be used to understand the status of the vegetation. It can be used to assess different kinds of damage done by wildlife, by insects, by weather conditions like wind and rain. And basically, these use cases build the platform what we have. And if these use cases are not enough, then we can easily create new use cases, and that's happening quite often these days. We are just started 2 years ago, so we're still building up the capabilities of our platform, and we created a workflow which makes it possible to create a new use case just in a few weeks. So from identifying the problem, which could be a new weed in a new crop vegetation, which one of the customers needs to detect, then we go there with drones, or actually drone pilot partners go there, they capture the images. We train the AI to recognize and measure what's on the pictures. We build the algorithm, and we make it ready for the customers to use in a couple of weeks. We can publish it in our platform, and then they can see where that wheat is growing and what is the status. All right, so let me go into more details and give you a couple of use cases which we already have, which we already give to our customers this season, and which we are going to give to our customers in the next season. So one of the use cases is missed tassel detection. The tassel is this flower part on the top of the corn. And that's what generates the pollen, basically. That is very important in hybrid corn, that we remove that part in time from the top of the male corn. So hybrid corn has a lot of importance in the food chain, because that's what gives the highest yield, and corn is a very important source of food. And you probably also know that in Europe we don't do GMO, so the only way to come up with better and better corn hybrids is to cross-pollinate corn and to create new hybrids. For that, basically what agronomists do is that they sow two kind of corn on the same field. If I just want to simplify it, then one row of female corn, and there is another row of the male corn, and the female and the male. The technology of to create hybrid requires that this tassel, the top part of the males, is removed in time. So, from the females is removed in time, so the males can pollinate the females. Okay, and that requires very big precision. Actually, 99.7% of these tassels needs to be removed, and that's a big challenge actually, because there is a lot of field where this process needs to be applied. Just in Hungary, where we live, there are 30,000 hectares of hybrid corn, and there are 100,000 corn crops on a hectare. So a lot of work, which is usually done in a combining machines and manual work. And the value what our solution provides here is that we can fly over the fields, detect the tassels, and tell the agronomist where are the left ones, and how can we where do they need to go and remove them. Okay. This is how it looks like. These are the images our drones, the drones take. You can see that it's very high resolution. We use less than 0.5 millimeter per pixel GSD to be able to recognize the tassels, because the tassels actually hide between the leaves. They need to be removed at a very early stage. So here on these images, you can see that these are the tassels in between those red squares, and on the top of the image, on top of the screen, you can see what the AI sees, basically how the AI is recognizing these features on the images and giving the information to the farmers. So that's one use case. The other use case which I bring you today is rugweed detection. So rugweed is a very bad weed in our region. It's not only bad for the vegetation, but it's also a huge problem because its pollen is causing a lot of allergy. I don't know if you have it in your country. It's a big problem where we live, and also the government regulates the farmers to remove that weed. So we can use that technology, the same technology, to detect where the weed is growing and where the plants are on the field. We had this pilot with Cortiva Agroscience this year when we used our technology to detect this rugweed in sunflower and give an assessment where do they need to spray and kill the weed, or to apply other technologies to remove the infection. Okay, so
sorry, Norbert,
yeah.
just one question I see that we have. So Joseph is asking, so what kind of camera are you using? Do you like use simply an RGB camera, or are you using a multispectral camera?
Right. So we need very high resolution, and we need to see basically all the features of the plants to be able to apply our algorithms. So we use RGB cameras because of resolution. Now, the resolution of multispectral cameras, unfortunately, they are not there yet, where we need to have them.
All right. Well, thank you.
Thank you very much. Okay, so let me give you an insight how we use UgCS and why we chose the enterprise version of this platform. So what we do has quite a lot of special needs. I think that what we do with the drones, not very few companies do actually. And these special needs had to be supported by a platform that make this whole thing possible from the data collection perspective. First of all, we have very rigid settings. When we want the pilots to capture the data, then we give quite a lot of settings and details how they should fly, whatever elevation, what camera angle. We don't always use the camera to face down. Sometimes we use a pitched camera angle. We have to make sure that we capture everything on the land and we don't miss a couple of meters when we design the flight. So we needed something which creates this in a way that the pilots doesn't have to set everything themselves. We can create these settings centrally. There is less room for errors. Sometimes we need to complete our missions in a couple of days, and there is no room to miss that time window when you can measure the vegetation. And so we really need just one shot, and we need to capture the data right. We needed a lot of special settings, so which UgCS gives us to be able to set every parameter basically of the flight. And we needed an API that we can publish all these things to the software without lots of manual work, because we designed the flights centrally, and you just want the drone pilots to complete the flights on the field. The other thing is that we use very high resolution. That requires flying low. So we usually fly between 10 and 50 meters, and that's has to be supported by the platform we use. Terrain follow is a critical feature, because sometimes we just see like 5-10 meters of elevation change, and we need the same quality of data, the same resolution from every piece of land. And as I said, we have to be sure that we don't miss and we capture everything from a field. And the third thing is that we have a global solution. So what we provide is working everywhere on this planet. We have customers from different continents. So we have to have something which works everywhere, which provides support to to different drones, which has elevation data everywhere, which is easy to set up because we have the onboard pilots to complete our missions in different countries, and we want them to be able to use our technology without too much hassle. They don't need to bring too many things to the field, like they don't need a notebook, they don't need to measure things, they just go there, they connect the drone to their tablet or mobile, and they are able to complete the data capturing. Okay, and we also need these enterprise features a lot that we are able to oversee what's happening from a control center we have, how many pilots are flying, where are they with the missions, and these kind of enterprise features like data security, and that we have logs from the flights that we can later analyze, and so on. Okay, so how we are setting up a flight plan, basically. So what's happening is that the customer comes to us either through the software or through a phone call, and asking us to run a mission. Give me stand counting from this and that field. So our start is that we need a flight contour for the field. This is something either the customer gives to us or we create it for them based on high quality and fresh satellite images. And that's what basically gives the borders of the mission. We also optimize the flight to the use case and the drone which are going to use for the flight mission. We both support everyday commercial drones, Mavic and Phantom series, and we also have support for the expensive enterprise drones, which can capture much more data at once. So it's a combination of possibilities and need. What we do is that we generate segments for the flights, which are achievable with one battery. So what that means is that the drone pilot doesn't have to take care about where to restart the mission from, and this is also makes possible that there are multiple drone pilots working on the same data collection mission. Once we split up the mission into smaller chunks, then we upload it to UgCS. That's also an automated task. We also do some manual checks to make sure that we are not crossing any airspace and there are no power lines and these kind of things. And then we send a mission to the drone pilot, and we also provide them an on-call support so they can anytime call to the control center and just say that, okay, I have an issue here. Can you please change the flight plan? And it's done centrally, and they just get the new flight plan on their mobile in a couple of minutes or even less. All right, so let me give you a demo how it looks like in real life in our platform. So let me just quickly stop the share and change to the browser. If you have any questions meanwhile, then maybe this is the right time to answer. Gustav, do you see any questions should be answered now?
Currently, there are no open questions in the Q&A,
right.
So I think we can proceed.
Okay, thank you. Do you see the application which I'm sharing?
Yeah, we can see it.
Okay, cool. Okay, so what you see here is basically the Proofminder platform. It's a web tool. You can access it from anywhere. What you see is the map screen, which is basically the result scheme. So this is what the farmer sees when we assess their vegetation. Okay. And what I would like to show you today is a stand counting use case for commercial corn, which is about counting how many corns emerged after they were planted. Okay, so this is our field which we want to stand count. Let me just give you the contour. So that's actually, this is 45 hectares, so quite a big land. This is the contour what we get from the customer, and this is how we split it up for segments. This has been split up to 30 smaller chunks. So each of the squares are basically roughly 1.5, 1.6 hectares, and that is achievable to fly within like 16 minutes with the settings we use with a Phantom 4 drone, and that means that they don't need to change the battery between just between these flights, not within the flight. So the pilots can just upload and run segment 0, segment 1, segment 2, just change the battery in between the segments. Okay. Let me just pop up one of the segments to show you how the data actually. It seems that the system just timed out while I was presenting. Just let me log in again.
No problem. It's called the demo effect. Always happens.
Yeah, it's happening a lot. All right then. Okay, it's coming up. Hopefully. Yeah, so let me just show you how the data looks like. Okay, that we capture with the drones. Okay, so let me just select one of the segments and show you the process data, like this one. So once the pilots are completing the mission, they send us the data, they upload it to the system, and then we are going to build an orthomosaic for stand counting. We don't always create an orthomosaic in our system. It's not always possible, but for stand counting, we do create an orthomosaic. You can see that this is a very high resolution image. So you can see that this is a tractor wheel. It's probably like 40 centimeters from side to side. So these are the line of corns. They're very small, like 5-6 centimeters, just 4 or 5 leaves. That's the ideal state when you should run distance counting. What's happening is that our AI algorithm is looking into the image and actually counting each and every piece of corn that is visible on the image. Let me just scroll up here and show you that how it looks like when there is a wildlife damage on a cornfield. So what is happening is that boars just go on the field and they like to eat the corn seeds, and that looks like this. And you can see that when that's the part of the damage the red dots are the corn itself, and you can just extract a lot of information from this. And as an agronomist, you can use this to turn to the authorities and ask for compensation because of wildlife damage. You can see if your equipment, the tractor, the sowing machine, they work properly. You can assess what's the different reasons why you don't have the amount of corn which you wanted to have. Okay. We also process this information and present it on a map, so that it's easier to understand. So we calculate the average number of corn plants on the field, and we provide a heat map, which is where the green is darker, that's where you have more corn. When it's lighter, then you don't have enough corn there. And you can compare it with actually, if you did differentiated sowing, that's a practice which is more and more common in agriculture, to put more seeds where your field is stronger and put less seeds into parts of the field when you cannot expect that much growth because it doesn't have enough things to make your corn grow fast. Then you can even compare the results. So as you can see in some parts of the image, like here, it's darker, it meets with the sowing zone. In some parts, like here, it doesn't meet with the sowing map, so you can see that somehow this part of the field couldn't even help the corn grow, or there was some sowing problem. Okay, so this is how it looks like. Everything what we measure is geocoded, so it's a map. We can put everything on our on the map. So basically, we know the coordinates of each and every corn on the field, and then we can even follow the development of a plant through the whole season by this. All right, so let me switch back to the presentation and hand over to Gabor to talk about our experiences on the field.
Thank you very much. Can you hear me okay, first of all?
Yeah,
okay.
We can hear you.
So thanks. So I will talk about the practical usage of the software and the best practices that we gathered during the seasons that we worked with the UgCS software, and also working in the agricultural field with drones. So can you go to the next slide, please? So I would like to give you a couple of practical tips, hints, how to use the drones and how to use the softwares. And the first slide is just before leaving home, because it's really easy to forget something, and then you travel a couple 100 kilometers to do a job, and then you find out that you missed some critical part of your mission, and then you have to travel back. So we suggest you to check the equipment before you leave your house. So anything that's strange on your drone or your batteries, that should be a warning sign. For example, the cracks on the whole hull of the drone, or if you have damaged batteries or some puffed batteries that you shouldn't bring with yourself, or if your cables are a little bit damaged that you connect your drone and your remote controller, you should replace them before you leave. It's really useful to check the battery percentages, the battery levels before you go, because it's the best if you finish the charging before you leave, because it can drop several percentages overnight, and then you might need to charge those batteries on the field, which might not be easy to do. Drone pilots tend to forget to check the KP index and the weather forecast before they leave, because especially this summer we had the case, I think it was in July, when we had a very high solar activity, and I think sometime it went up, the KP index went up to 6 and 7 points during the summer, and we faced a little bit of GPS issues where the GPS was not that exact, so we had a little bit of problems with the flying. So it's always best to check it before you leave. And also the weather forecast is important, because the Phantom 4's factory wind tolerance, or at least what they say in the details, is 10 meters per second maximum. So if you are facing high wind, it means that maybe you are not able to finish your mission, or you have to stop for some time, and then you can lose a few hours or even a few days of work. You always have to check if you pack sufficient batteries. With UgCS software, Norbert already showed that we can split the missions into small segments, and then it means that we can plan how many batteries do we need in the best case scenario. So if we are working with a large field, and then we split it up for 30 different segments, then it will mean we should bring at least that amount of batteries, but we are always trying to plan more than that, because we always face some issues we are not planning for, and then we always over plan with the battery numbers. You always have to bring more than you need. Our experience is that for Phantom 4 drones, if you have 8 batteries and a multi-charger which can charge 3 batteries in parallel, that's sufficient for a continuous flight for the whole day. But also you need a generator with yourself, and that's for a Phantom 4 drone, it's 650 watts power at least, and it can charge 4 batteries and your remote control at the same time. If you have an enterprise level drone, for example, a Matrice M300, then you will need a larger generator, more than 1 kilowatt of power. And then the best tip, I think, from this slide is to pack extra pieces of all the consumables, which I mean is the propellers, the SD card, the cables, and so on, because it's really a key part of your mission. It's a small thing like an SD card, but if you have just one and maybe you lose it on the field, in the cornfield, or during your trip, or something is not okay with the card, then you can travel back home, and then you have to, or even in the next town, you have to drive in and buy another one, and you can lose some time. The next slide, please. So that was about planning to leave your home, and then I will talk about the mission site, how to do things at the mission site. So when you are flying at the first time at a spot at a certain field, it's the best practice to look around the borders of the field for maybe branches that can be inside your flight plans. Maybe you could check the Google Maps and it looks okay, but there was a storm a few days ago, and there is a dry branch which is now broken, and it's on the way of your drone, and it can cause some problems. Sometimes we are facing the issue that we are planning the missions, and the farmers forgetting to tell us that there is a huge irrigation system operating on the field. And if it's a GPS system, or it includes a GPS system, it's an automated irrigation system, it can cause some trouble with your drone. So we faced the issue when it was just they switched on the irrigation system, and suddenly the drone lost all the connection with the controller, and it started to come back because the interference of the GPS system of the irrigation system was too strong. Or sometimes they just forget to tell us that there are some certain workers on the field, and we have to be careful when flying above them, and we need to calculate that we need to switch maybe flight plans to avoid flying above the workers and so on. If you can have a spotter with you, and you can send that person out and check for branches or obstacles, I think this is the best way to do this. We always suggest to check and adjust your return to home altitude all the time, because sometimes it's just enough to say, okay, 20-30 meters return to home altitude is more than enough because there are no obstacles. But you forget about it, you go to the next site, you are in a rush, you forget about it, and there is maybe a forest, there are some buildings in the neighborhood, and then your drone will be stopped because of the return to home altitude is not sufficient, or it's in some ways something is in the way to come back. Also check your camera settings according to the current light conditions, because sometimes if you put the auto button, it's not the best results. So we usually adjust the camera settings every time if we go to a new field and we have some sunny weather. We always check the settings and adjust it manually. Because of the special mobile phone thing. So for example, we use our mobile phones sometimes to have the drone, to put it on the drone's remote controls, and we are using it also as a hotspot. But sometimes if you are receiving a call, the Wi-Fi connection is stopped. At least it's happening on my phone. So what we do is we always bring a little mobile device with us, a separate hotspot, and we start it immediately when we set up camp at the site, so we can have uninterrupted Wi-Fi connection even if we receive a call or if something is happening there. And it's the best practice to check the wind velocity at the site, because you can see it in the forecast applications and maybe in the TV, but it's the best if you go to the site and check it for yourself at the local place. The next slide, please. During the day when we are working, we are suggesting you to save the data from your SD card from time to time. With the new SD cards, 128 gigabytes or even more, it's easy to forget about it, because you can handle a whole mission without doing any saving, because the capability of the SD card allows you to do that. But something can happen, you can lose the data, and it's always best to say, okay, you wait an hour or you work an hour and then you save the data from your SD card. While you are doing that and you are copying the files to your laptop, you can let your drone rest a little bit. You can leave it out in the open, let the wind cool it down a little bit. You can always check the props and the hull, and for damages you can always manually or visually check your drone if something is out of the ordinary, and you can use this time for these kind of things. But you can also check your photos, which is, I think, really important, because if you create a few thousand photos and you only find out at the end of the day that your images are blurred or there were some issues with your camera angles, then you lost the whole days of work. But if you are doing some SD card copying, then in the meantime you just randomly check in the folders, and then you quickly go through some of the pictures. Even you can upload to the system that we are using, and then we can already start processing. And after a few minutes, the process can happen, and then we can see some results, and we can say, okay, let's go ahead, or we need to change something. We suggest you to only fly with fully charged batteries, because we found out that if we have batteries, if we start the mission with a battery which is only, let's say, 90-91% charged, we always face the issue that it was that few percent that was missing to finish some flight routes. So it's really annoying when you are missing only the last 5 to 10 pictures of a mission, and you have to bring the drone back, have a new battery, put it back, and then finish the mission with another battery. So if you fully charge your batteries and start the mission with those things, you can avoid these mistakes. It's our experience is that with the Phantom Pro drones, you can cover around 35 to 40 hectares within a day using this 0.5 GSD data. And but this is the maximum what you can say if everything goes well, without any stress and without any rush. Because if you want to get more land covered, maybe you will be a little bit too stretched with your resources and with your time, and you will start doing making mistakes, and you can end up maybe with more mistakes, and you can have a problem at the end of the day. So this is our best practice to say, don't plan more than 35 to 40 hectares per day. With the UgCS software, it is really a good feature that you can quickly recalculate your missions, your flight plans, even from a remote office. So let's say I'm working on the field, and then I find that the irrigation system just started to work, and we were not aware of this in the previous days. So I can either do it myself on my laptop at the car at the site, or I can call Norbert and then tell him the situation, and he can quite easily, in a few seconds, he can recalculate the plan. I can use my remote controller to download the new flight maps again, even if I'm 200, 300 kilometers away from him. And then in a matter of minutes, we solve this issue. So I think this is always a good thing to have a supporting partner, maybe in an office, because in the field, sometimes you're not able to see the screens, or you don't have time simply to recalculate these things. But you can do this with UgCS. It's always possible to do it remotely and then have a fresh flight plan and rerun it. Next slide, please. So the best practices in general, everything will be really hot in the summer. Everything will be maybe shutting down. So for example, tablets and phones, they tend to overheat in the summer. We suggest you to remove your covers from your tablets or from your phones, your protective covers, because it just makes everything worse. And the problem with the drones and the batteries is that the drones can handle the heat quite okay, but the batteries, you cannot charge them until they cool down. So you have to wait a couple of minutes, or even sometimes 15, 20 minutes if it's the hot summer day, that they cool down, because you are not able to start charging before they cool down. So we sometimes just jump in the car and then start the AC and blow the cold air to the batteries to let them cool down quickly. But you have to make it, you have to plan for this when you are making a plan on your timings. Unfortunately, the screen light or the power of the screen lights are not sufficient on the field. So tablets, phones, you are not able to see them clearly on the field. So use shades whenever it's possible. You can get this from drone shops and everything. It's better if you can cover them. And as I said earlier, if you are doing some check on your drones, or if you are copying files to your laptop, let the equipment rest for a few minutes. It's just a matter of minutes really, but it can help. Sometimes we face the issue that the Phantoms sensors were a little bit too hot. They were overheated and they send some false data. But if we let them to cool down a little bit, we had we didn't have these problems anymore. And one last thing, that UgCS has this very cool feature that you can track multiple drones at the same time. So we had a large field covered with 4 drones at the same time, and we could see them all at the same laptop. And if 2 drones, for example, fly too close to each other, you get a system message, a warning sound, and a system message that there is a collision error, there is a collision warning ahead. And then you can, even if your drone pilots are not paying attention, you can always warn them, and they will be always warned by the system that something is not okay. And it's really a cool feature that you can track these drones, even the percentages of their batteries, their flight attitude, you can see everything. And I don't think there is other software that can have this feature built in. I think that was all from my end. Thank you.
Thank you. Thank you very much, Gabor. I think you can sense from what Gabor said that there are quite a lot of things to take care about when you're on the field. Enough for a pilot to do. I think planning the flight should be not part of the things the pilots are doing on the field, and this is why we love to plan our flights ahead and use the enterprise setup to publish the flight plans to the pilots. That's one thing. The other thing is that probably you also see from what Gabor said is that for agriculture, there are a lot of land to do and to fly over, especially if you want high resolution images. And you really want to maximize the time when your drone is flying and covering land. Gabor mentions that we can cover with smaller drones 35, 40 hectares per day. That is basically 8 hours of effective flight time per drone. With bigger drones, it's even more important that they are flying, that they are not sitting on the ground while you're just changing settings and trying to figure out what to do and where to fly, because that's just expensive for the drone pilots to spend time with unnecessary settings. And I mean, what this software does is really a great help in that as well.
Yep. So thank you, guys, for the presentation. And I think now I'll just quickly share my screen, and I think we can probably actually move into the Q&A section. So see, there are some questions. So let's get started with that so you can see. So the first one is, what specifications of a PC are required to process such high quality ortho mosaic data?
Right. So let me take this one. So it's our system takes care about the orthomosaic creation. It's totally on our end. We use our cloud infrastructure for that. It's a very complex process, and it's very compute intensive. So we use a cluster of computers to build these images very fast. It's not possible on a desktop at all.
Yeah, so basically everything is done by remote computers. I guess that's the answer.
Yeah.
That. Okay, so I'll mark this one as answered. Next one is from another one of our listeners, watchers. So this is about, in which plants other than corn can you get clear results, and what problems can you detect? Yeah,
so we can provide, we have algorithms for stand counting corn, sunflower, beetroot, sugar beet for sure. And we can create any other vegetation where the plants are actually can be distinguished on an image from each other. Basically, so we can theoretically count trees, count animals, count hay bales on a field, everything which you can count on yourself. We can automate that process. So if you have any idea what to count, then just come to us. We have a partnership program for new use cases, and we can get it implemented very fast. That's one thing. We are able to measure a surface area of different kind of weeds. We have vegetation index calculation, either the usual ones you have in other software, and we have damage assessment algorithms for wind damage, for wildlife damage, and for water logging.
Yep. Okay. So I hope that this answers that question as well. Another one, I think maybe I can try to answer this, is from Andrew. If there are any abrupt changes in elevation, are you using a rangefinder to ensure altitude consistency? So basically, by default, when you're flying, as I understand, like your flight altitude in this case is about like 10-15 meters. So I think in those cases should be sufficient with UgCS ability to follow the terrain. However, I also wanted to mention is that actually here at SPH Engineering, we also offer true terrain following kits. So if you need to follow the terrain quite closely with a very with a very low margin for error, then you can actually use real-time data from the altimeter. So if you go to integrated.ugcs.com basically search UgCS Integrated, then also you'll be able to see the system that we offer for large DJI drones, so M300, M600, and M200 series, as well as custom Artbelt and PX4 based drones. So it has the rangefinder and ability to follow the terrain with true terrain following. So let's mark this one as well. Then about the Phantom 4 Pro that you're flying, what's the maximum GSD that you have achieved with your drone? If you can maybe mention that.
I'm not sure that what's the maximum here is the highest or the lowest, but I can tell you the range. So some of the use cases when we really have to see like insect damage, which is very small, then we go down to 0.3 millimeter per pixel. The upper scale is whatever the low allow us to take. So like it's like 2.5 centimeter per pixel.
Yeah, well, I'm assuming in this case it's probably meant the minimum GSD. So basically, what's the highest amount of detail that you can see?
Yeah. So we can safely fly at 8 meters constantly, and we have very good experiences with the elevation data the software has. It gives us the possibility to fly very low.
Okay, and so now next one would be from another one of our watchers. So in case of ragweed, do you also deliver a map for the sprayer?
Absolutely, yes. Thank you for this question. I totally forgot to mention this, but you can actually export any of the heat maps we have, and then you can use that model with your sprayer drone or with the classic spraying tractor, any kind of format which you can imagine is exportable from the software. So like KML, shapefile, GeoJSON, everything.
Okay, so I think that answers also that. And then basically the last question that we currently have is, have you tried this on commercial potato production cities for in-season nitrogen and yield prediction?
Not yet. Potato is on our radar for next year. If you have a use case, then come to our website, contact us, and we're happy to take that prioritized on our list.
Yep. Okay. And so then I think as far as the questions go, then that was it. One thing I also wanted to mention here kind of towards the end is if you want to learn more about UgCS, then you can visit ugcs.com or visit our shop. So this would be shop.ugcs.com. So I'll just quickly maybe share the screen there with you. So if you go here, then you can actually see what licenses we offer and what can you get. If you just want to maybe try UgCS first, then you can go here into subscriptions, and then we also offer a 21-day trial for which you can apply. And then within 24 hours, normally we also send you the trial code. But if you just want, maybe, for example, play around with flight planning, you can simply go to ugcs.com, then go to support, downloads, and you can actually download the software and use it even without any activation key. You won't be able to use it on a real drone, but if you just want to play around with flight planning, see how it is, then you can actually also download this at any time and try it out. So there's actually now one more, I'm not sure if it's a question, but yes, from Andrew. So when you export your heat map to a conventional sprayer, is it plant by plant? If you understand the question.
Yeah, it doesn't make sense to spray plant by plant. Theoretically, it's possible. We used to adjust the heat map to the working width of the sprayer. So for like a spraying drone, it's like 8 to 10 meters usually. So you can export that resolution for your needs. Yeah, and I just want to suggest the same to come to our website. There is a section for drone pilots. If you're interested, then you can come there. You can register. You can learn more about our services.
And then I suppose one final question would be, so regarding wildlife damage.
Yeah.
So if you can do wildlife damage, well, I suppose wildlife damage detection, can that be done from higher altitude, perhaps 250 feet or 80-meter altitude or more? And then John says that his constraints are time, no more than 2 batteries to cover quite a large area in that time. So basically, can you detect from a higher altitude? I suppose that's the essence of the question.
Well, so if you have the camera which is able to capture this high resolution, then it's possible. So basically, it's depending on a little bit on the crop, but for the usual crops, we can go down to 1 millimeter per pixel GSD, and with a P1 camera, probably with the teleobjective, you can fly around 60 to 80 meters and still get the data which is suitable for this use case.
Yep. So I guess then probably the setup, John, you would have to look into would be the DJI M300 plus the P1 camera, and then I suppose with that
yes,
you can already detect features from still quite a high altitude, while still retaining quite a high resolution of that. And yeah, so with this question answered, I think that actually probably concludes our webinar, unless there are any other questions. So I just want to thank you first to both of you guys for taking part in it. It was for me also actually very interesting to learn more about how our software for flight planning is used in agriculture, and to learn more about what you do. And also, of course, thank you to everybody listening and watching this webinar. Like I said, the recording will be available later on YouTube, so we'll send you that. And yeah, so you have our site, you have Proofminder's site, so you can go there, check it out, see more info, and yeah, so hope to see you in future webinars, and let's all stay in touch.
Thank you for inviting.
thank you. Thanks for all.
Thank you for your
Thank you very
attention.
much.